basically sees. So I'm going to start it now. Hello, everyone. Welcome today to our webinar session once again. We'll wait maybe a couple of minutes for maybe just the last few people to arrive. But basically, this week, we are very excited to have Nathan Luke from Geometry Gym giving a short presentation about their workflows in Karamba and Geometry Gym. We also have Jon Mirtschin here attending too. He'll be also offering some sort of insight into the development of Open BIM and Geometry Gym itself. And we also have myself, Matthew Tam, and Clemens from Karamba here. I'll just wait a couple of minutes just for the last few people to arrive. I'm just going to give a short introduction about today's session. So there'll be a short presentation from Nathan about Geometry Gym. Geometry Gym was started around 10 years ago by Jon Mirtschin. Actually, very similar to when Karamba first started, about 10 years ago as well. So it's a big milestone for both of us. And Geometry Gym basically enables BIM generation in Rhino, Grasshopper, and as well as interoperability between multiple platforms such as Revit, Tekla, ETAB, Sophistic, SpaceCast, GSA, just to name a few. In today's session, Nathan will be talking about how to export the Karamba3D model directly in SAP 2000 using Geometry Gym, how one can export an existing structural analysis model into Karamba3D as well from GSA, and then also demonstrating a new tool from Geometry Gym where you can directly bake into Revit using the Rhino.Inside Revit capability. So just a general introduction between of the speakers. Nathan and Jon are both based in Victoria, in Australia. So we're glad to have them join us from across the ocean. Nathan is an engineer based in Melbourne. He's involved with software development, training, and support of Geometry Gym. He's an expert in parametric design, BIM data workflows, optimization, and the rationalization of structures, and automated fabrication and drawing production. With Nathan, we have Jon, who's the director of Geometry Gym. He sits as a director on the board of Building Smart Australasia and is a strong advocate for open BIM and IFC development within the architecture, engineering, construction industry. And of course, myself, Matthew Tam, and Clemens from Karamba3D are also here. So with that, I'll give Nathan the screen. If you can start sharing your screen, Nathan.
You see that?
Yes, it's all working now.
Great. Thanks, Matthew. Thanks for the nice introduction, and thanks to Karamba3D for allowing us, I guess, to present on some of these things that we've been working on, for a fair while now at Geometry Gym. Just a little bit, I'll quickly go, I guess, a bit more about me. Grew up in a small country town in Victoria in Australia. Did a degree in civil infrastructure engineering and sort of graduated as a structural engineer and worked for Oricon in the building structures group in Melbourne for 6 years. Predominantly, most of my time there was working on a small, well, reasonably small stadium. You may have recognised it watching the Australian Open, the Margaret Court Arena. And then have been, I guess, lucky enough to work on a couple of other stadium projects and some other sort of funky type stuff, which kind of drove me in this in these types of, I guess, parametric type structural workflows. I was also really lucky to work at Bureau Happold for a couple of years in their building structures group as well, on the Qatar Foundation Stadium, which is nearly completed now for the 2022 World Cup in Qatar. And then after returning to Australia from London, I've been working with Jon at Geometry Gym for a year and a half. helping him, I guess, develop the tools and as well as sort of do training and support and plugin development, and also other bits of specialist consulting and stuff. So yeah, I mean, I guess most of you hopefully have heard of Geometry Gym and some of the software tools that we provide. I guess we sort of like to see ourselves as trailblazers in this type of space in interoperability between BIM and structural analysis programs. Myself and John, both coming from a structural analysis background, does sort of lead us to I guess produce little bits of software that do facilitate these types of workflows, especially with available software like Karamba3D and stuff like that. We also have a third person working for Geometry Gym, Scott Beasley, who works on more of the BIM side of things, so OpenIFC and model conversion and stuff like that as well. But I'll talk mainly about the structural analysis stuff today. But yeah, as you know, we do have I guess a lot of different tools, mainly focused around Rhino and Grasshopper. That's how it's sort of been built over the last 10 years. So we have, I guess, Rhino and Grasshopper plugins that allow you to for Rhino IFC, direct transfer from Rhino to Revit, also Rhino to Tekla. So these are all plugins which allow, I guess, the generation of these type of models from Rhino and Grasshopper. Also, we've got a free plugin, Bullant, which is, I guess, has some tools which allow sort of for geometry creation, so geodesic domes, polygon packing and tessellation, and also some small mesh relaxation and stuff like that. I'm not sure if you've seen, John about 8 years ago did a recreation of the water cube and other types of structures using some tools from that plugin. And also stuff which I'll demonstrate today is some structural analysis plugins. And then with that, our importers and exporters for Karamba3D, which is what I'll go through today. So not just for structural analysis, but also you know, importing and exporting to IFC, Revit, and even Tekla. So yeah, as I was saying, we do provide our own structural analysis plugins, which are quite similar to Karamba3D. So they allow you to generate, I guess, a structural model using Grasshopper. Similar in the way that Karamba3D will generate a structural analysis model, but more specifically tailored to your everyday commercial structural analysis engines such as ETABS, SAP, Robot, GSA. So not, I guess, specifically trying to do analysis. We're trying to facilitate the generation of those models, and more in a, I guess, a program specific type of way as well. So if you have specific parameters that you would need to set in ETABS or another certain program, we can specifically tailor those plugins for those types of things, and also more advanced analysis like stage construction analysis and more advanced combinations and analysis tasks. Some of our plugins, which I'll demonstrate, we also allow the automated solver triggering. So triggering a solver, an analysis solver from Grasshopper and retrieving results within Grasshopper to allow you to start to do, I guess, optimization as well. And then some of our plugins now also allowing automated design triggering from Grasshopper as well. So allowing you to use an analysis program such as SAP to trigger their design engines and then retrieve, I guess, real-time feedback on those types of things. So I might jump into Rhino now and just give you a bit of an understanding on some of the tools that we do have for Karamba. So with Karamba, we basically provide, and when Grasshopper loads, I will show you this. So yeah, with each of our structural analysis plugins, the Karamba import and export comes included with those plugins. So you won't need to install anything additional. As long as you've got Karamba installed on your PC, these should automatically be generated in Karamba3D. So in Karamba3D, out of the box, I believe there's the DSTV one, but as you install, say, the SAP 2000 Geometry Gym plugin, you do start to get these additional export components available. And then also under the GG structural analysis, you'll see the structural analysis components for Geometry Gym become available as well. I'll just quickly note here that if you are trying to follow along, some of the components and you may not be available on your machine, or some of them might not be working quite as well as what I'm showing here. We have made a couple of updates recently, but if you are wanting to, I guess, try these after, you can just let us know. We can provide you with the most recent installs, or if you are wanting to trial these plugins after, if you, in your trial request, just let us know that you're looking to use Karamba3D importers and exporters, and we can send you those plugins. I will show some stuff with the Rhino.Inside Revit as well later on, and to get those, you'll need to install a special Karamba installer from our website, which is the Rhino 6 Karamba. Sorry, Rhino.Inside is Rhino Whip Karamba. All right. So the first thing I'm just going to show is basically how we can export a Karamba3D model to SAP 2000, and we'll just, I guess, show how it works. So I'm just piggybacking off some of the great work that Clemens and Matthew have done in their first couple of tutorials, and developed. I was going to show the other one. First. So they've developed this truss model, and it is a matter of actually just going to that export tab in Karamba, selecting the Karamba to SAP 2000. There's one component which has 3 imports: enabled, model, independent. The enabled basically sends the model, the Karamba model, to SAP, and this independent basically, if I had other SAP 2000 components from the Geometry Gym plugin on this canvas as well, I can keep those 2 models separate in the model database, or I can join them together to create, I guess, a combined model. So I'll just hit the true. And what this does is opens SAP 2000, converts that Karamba model into SAP 2000 elements. It's just opened up another screen. Just something there, whenever you're using Karamba, always make sure your Rhino document is in meters. So you'll see that the geometries come into SAP now. I'll just turn it on to extrude. So member sizes, and I'll just change the sections. So all this has come into SAP. I'll just close this view. I can also look in here. Load patterns have come in. In this particular Karamba model, there's no self-weight multiplier applied, so so that's okay. I can simply run this model. SAP just requires you to save the model. I can see my deflected results. The other thing I was going to show, which I'll see if I can, just that the loading had been applied. So you can see the loading has been applied from the Karamba. And then I'll just check to see if my deflection results are similar. So these are in meters, and I'll just change them so similar to my Karamba output. So I've got a 1.12 centimeter deflection. And if I go back into Karamba, I can see that I've got a very similar type major displacement. So that's I guess that's a SAP 2000 example. We have a lot of different other I guess structural analysis plugins that you can do a similar thing with. So I was just going to, I mean, this is quite a simple example, so I will just show you the other example that was done as well, which is a bit more complicated. And it's a similar thing. So again, I can see the member sizes for the this come in. In this case, we do have load cases. In this case, we do have dead load applied in our load cases. So this does come into SAP as a self-weight multiplier. And I can again see the different frame loads that are applied for the different load cases. So this is similar to, I guess, the process that we've had around for a while. The other process that I'm pretty excited, I guess, to show you about is what we can do is for importing. So I'll just select to our. So we have an export, and we also have the ability to import GSA files, or any type of the structural analysis plugins that we offer. So in this instance, I'm importing a GSA file of a truss that we've defined, and this component basically takes a file path and then translates the GSA information into Karamba information. So what I've wanted to do here is basically optimize the section sizes using the Karamba3D section size optimizer. The sections that have been generated in this GSA file are not standard sections, and you may get, depending on what you're working on, you might get a structural analysis model or a model that doesn't have standard sections, or sections from another country that you might not be familiar with. The GSA Karamba has a really good function which allows you to match section sizes based on section properties. So what I've done here is I've input the sections that have come in from my GSA model. I've picked using the cross-section range selector in Karamba which country and which shape and family that I want to select from. And what that does, I can then modify the cross sections from my GSA model to apply this family type to this Karamba model. I can then assemble my Karamba model from the outputs of the GSA to Karamba component. And then I see the model that I've generated, which has come from GSA. So, and you can see if I just turn off this other one, you can see that based on the section sizes that have come from GSA, I've got an IPE 450 for the chords and an IPE 360 for the webs. Now, if I run that through if I analyze that model and then I run it through the optimized cross sections, I can then I can view an optimized model based on the loadings that have been provided. So and compare those two. So, and also what this does is at the start I had all these webs as the exact same member. This Karamba has optimized this now, so some of these webs are different member sizes, which is quite helpful when you're trying to optimize these structures. And then what I can do there is push that model back out to GSA. So I can push that optimized model back to GSA and then rerun my analysis in GSA if I want. So that's quite a helpful workflow. I think for using, I guess, the best features of Karamba3D from an already generated model from a structural analysis. The last thing I wanted to show you on the structural analysis side is a new feature that we've integrated into our Geometry Gym components. So what we can do now is, as we explained at the start, our tools do allow you to, similar to Karamba3D tools, allow you to generate structural analysis models with components in Grasshopper. So this truss that you see on my screen has been generated using the Geometry Gym components. So in our Boolean plugin, we have the ability to generate cross sections, either from values or from catalogs, generate cross-section properties for GSA, similar to Karamba, assign a center line to a property, and build up a structural analysis model from that. Also, you can assign loads and so on. Up till this point, we Geometry Gym haven't, I guess, provided much in the way of visualizing the structural analysis model as you're building it up, and that is where this new tool starts to come in. So what this allows you to do is generate that structural analysis model in GSA, and we've got a new component which is a GSA to Karamba, which is actually stored within the Geometry Gym GSA set of components. And what this component allows is basically an on-the-fly conversion of a Geometry Gym structural analysis model to a Karamba model. So all this is the only input is enabled. So if it's true, basically it continuously converts this model to a Karamba analysis model, where you can start to view, I guess, view the model, understand where loads are being applied, look at restraints, as well as, I guess, use the Karamba3D analysis engine to get preliminary, or to get those displacements, forces, prior to sending it to, say, GSA for further structural analysis. But this kind of allows you to, I guess, not have to fully duplicate all your components in Grasshopper, and allows you to get the best of both worlds when you're doing this. So just a bit of a look at how you can use the GSA solver within Grasshopper. I should point out that as I can as I update this, Karamba continually updates and provides feedback on this structural analysis model that's been built using the GSA components, Geometry Gym components. I can set, so I can use the GSA solver directly as well to check my my analysis results with my Karamba analysis results. So basically, I'm just querying the central node of the model here. What this does, sends it to GSA, performs the analysis, and gives me a result. So if I just decompose. And this unit is in meters. So it'll be 0.4 centimeters, and so it's quite similar to what I'm getting in Karamba. So I can run this when I want. So if I don't want this to be continually sending information to GSA, I can turn this off periodically, and then I guess periodically go back and check those results. So there's some of the, I guess, the structural analysis workflows that we're sort of working on, that we're sort of got available, I guess, at the moment, and definitely always looking for different types of improvements in those types of things. The other thing that is recent is Rhino.Inside and the ability, I guess, to directly bake Karamba models to Revit. So we've always had, I guess, the bake to IFC and then the ability to import that IFC file into Revit. This new tool allows, again under the Karamba3D set of components, you'll get this Karamba export Revit component, which is only available when you're working in Rhino.Inside. I'll just open that document.
Nathan, while that's opening, maybe I can just ask one sort of small question. In terms of units, so Karamba works with meters for its sort of calculation. How does Geometry Gym or your interoperability deal with this issue? For example, if you're working in millimeters or centimeters in Geometry Gym and then or in another program, is this automatically then sort of implemented in your export import sort of tool?
Yeah, it is. So as I was saying, I think typically, because Karamba is working in meters, you should always use meters when a model is brought in, say, or is imported from an analysis model. It will convert, I guess, those units to an SI unit within our I guess, our program, and then it will convert to Karamba units. So it will so it's a two-way conversion, basically. It converts into Geometry Gym to, I guess, an SI unit or our internal unit, and then we'll do a conversion to Karamba. In terms of our plugins can work in any unit the Rhino that Rhino is in. But yeah, I'd always advise that you use meters when working with Karamba. The other thing that we do allow for, I guess, generating loads, if I just find the load component, we do allow the ability to select an input unit, and that so for a node load or something, you can input a unit that you'd like to use, and it will convert that, or I guess it will convert it automatically to the units that Karamba are using. Does that answer the question?
Yeah, that's really cool. I didn't know that you could change the units, especially for the loads in the bullet. So I think that's quite useful to know.
So I had that already enabled, the Karamba export to Revit. So nope, don't want to save this. And you can so yeah, so you can yeah, so that also creates your analytical model in Revit as well. Oh. Revit's just crashed on. I can start off again. But yeah, so it creates your analytical model as well. The other thing we were talking about is being able to set different options and stuff when you are exporting directly from as well. Yeah, I mean, I can get that up again if you like, or else that's basically sort of the end. I guess I would say that you know that a lot of these tools are sort of still development, and we rely on, I guess, people using them and user feedback to improve them. So yeah, I definitely encourage people to, if they think that these are useful, then definitely give us some feedback on different workflows that they're trying to achieve. And we're always happy to listen and have that discussion as well.
Yeah, thank you very much for the sort of very quick sort of introduction into your tools. There was one question, I think we're not going to address it live. Someone was asking about Sophistic, and I assume export to Sophistic is also embedded in your tools. Is this correct?
We did have support for Sophistic. I think more recently, as Sophistic has sort of improved their IFC ability, we've sort of pushed the for Sophistic in general to use a more of an IFC approach. So instead of using the direct Sophistic, I guess, file format, we've sort of gone towards interacting with Sophistic with the IFC, the import and export IFC components, rather than having a standalone Sophistic component. I know it was shown there in the video, but in the introduction image. But yeah, that's kind of our approach at the moment with Sophistics, because I think their IFC import and export ability is quite good in that respect.
Yeah, I guess that then maybe also brings me to a question that I have, because it's in relation to Sophistic and maybe some other softwares and such as Tekla. So a lot of these softwares are developing their sort of own in-house tools that are working interactively in Grasshopper themselves, and sort of maybe where do you see the challenge now when they are also trying to develop their own tools in this sort of Grasshopper platform that we've been working with generally?
Yeah, this is probably a question for Jon, but yeah, look, I think in terms of Geometry Gyms' approaches, we are a bit of a niche. We are a bit of a, I guess we see ourselves as a niche tool developer, and these guys can develop tools, obviously in Grasshopper as well, but we are there to do, I guess, those more really complex things, and when people do come into trouble, they can sort of contact us directly, and we can help them sort of troubleshoot and get I guess those more niche types of problems sorted. Yeah, I don't know if Jon wants to expand on that a little bit more. But
yeah, I mean, I think it's great for users to have choice, really, because competition helps stimulate innovation and improvement. So it's a bit like why have Karamba in Grasshopper, but Karamba obviously solves in-house, in place, so it's a lot faster. So if we're sending models to GSA, there's that overhead of collating the data, sending to it, and getting the result back. So I think it's great that there's choice, there's competition, and the users then get the best tools. So there's advantages and disadvantages, and things that are good and not so good in comparison with all of these things.
I have one question regarding this IFC format. I mean, there's a standard which defines how IFC is set up and so on, but it seems like that the different programs like Revit and all those different tools have slightly different dialects, it seems, regarding IFC. Do you think that there will be a convergence in the future, or is it rather to be expected that they try to stay a little bit separate for business reasons, so that this interoperability is not implementable 100%, so to say?
It's a good question. I mean, when I first started implementing with IFC, I thought I'd just use the out-of-the-box Revit IFC import, but it pretty quickly became clear that I wanted to use advanced parts of IFC, including NURBS, and couldn't wait or rely on Autodesk to implement some of the advanced parts of IFC that I wanted to use. I think what is starting to become more apparent is even model checking and model validation. And I think that's what will start to drive more consistency across the different software if clients are demanding and doing that. So they actually can start to check that they get what they want. And if they're checking that from different sources, then you will probably get more consistency. So it is a real challenge. IFC is complex and capable of lots of different workflows. And to be honest, most of the implementations there are only for coordination. Whereas I guess what we're really showing and pushing is design transfer. So yeah, look, it all boils down to users and clients that are really clear about what they want and checking it, which I hopefully will help improve that situation.
Thanks.
Maybe Nathan or even to John, there was a question from the audience. Will the development of Strand 7 Geometry Gym tools continue? I'm not sure.
Yes, they will, and they have been continuing.
Again, it's all our work's driven by client requests and demands. So yeah, absolutely. We're working on all the tools, and it's heavily driven by what users are asking for. So if you're not seeing the functionality with Strand 7 that you want, then get in touch. We've been toying with the idea of using the Strand 7 API for a number of years, and we haven't quite bit that bullet yet. But so most of that interaction's via text. But yeah, if you're a Strand 7 user and you're interested in these workflows, then please get in touch.
I think I'll mention I had to unload some of the plugins just so it wasn't a mess in the Geometry Gyms Structural Analysis panel. Because but yeah, so what you're seeing on my screen is only two of the, I guess, available ones. Yeah.
Yeah, and basically, I think what people should understand is each of these different software exports have a different component as well as a different sort of installer on your website, correct? Yeah, and so if people are interested in exporting for a specific software, they should look onto your website where they can download this for that specific software they're interested to look for, and then like John already mentioned, if there are specific functions that they are interested in using, they should get in touch with you directly, with you or John, for example. And I think that's where the sort of expertise of your your group comes in.
Yeah, exactly. So yeah, as you mentioned, we do have so on our downloads page of our website, there is I guess the different plugins for the different structural analysis software, and so if you did download, say, the SAP 2000 plugin, you'll get the import and exporting Karamba3D for SAP 2000 if you've got Karamba installed, obviously. I guess the other thing that we are working on is technical documentation. So we do have a whole bunch of samples for these different plugins and stuff as well. So you can go there and download those as well. But yeah.
And I think we have one more last question. As a developer point of view, is it possible to clone Geometry Gyms repo and build it in Grasshopper for business purposes?
No,
if that question's about whether Geometry Gyms open source, that's if you want to see some of my thoughts about open source, I did a presentation about a month ago with the Melbourne Computational Group. So at the moment, Geometry Gym is closed source. We do have some open source parts of our development that we build on top of, but we basically license these tools to commercial users for revenues to work on them full time. So you can use the tools as an API, but the actual source code that does a lot of these conversions is closed source at this point in time. Maybe that will change at some point, but again, get in touch if you want to know more details specific to that.
Great, thanks for that. At the moment, I think we have addressed all the questions, and we're also over the 40-minute limit. But of course, if there's any other questions that we might have from either the audience, or if Clemens or has any additional questions.
I have one question. I did this export from Karamba to DASTV file, and this was really quite hard to do because the programs which read this file they slightly change from version to version. So how do you keep up with all the versions of the programs that you export the model to? I mean, this must be a huge work. Do you have automatic testing?
Lots of typing, Clemens. There is quite a bit of source code in there. I guess, I don't know, the approach I took 10 years ago, there's a lot of common code. So, and using IFC, I know a lot of others don't have the same success, but we have basically been able to build specific bridges using IFC as a central funnel for that information. So it's probably not quite as much as you expect, but whatever technique I chose 10 years ago has got us thus far with supporting many different versions of software, as you see. So yeah, I don't know. Yeah, if that answers the question, but yeah. Interoperability is not easy, that's for certain, but that's where we can really help users with actually how to get more success using without rebuilding lots of models of the same thing in lots of different applications. So.
Yeah, it definitely adds value to the model when you can do different things with it, because the application providers, they want to rather lock you inside the environment, of course. And yeah, thank you for answering the question.
No, thanks for having us help present this.
I think that's all for the questions for now, and thank you for once again, Jon and Nathan, for giving the presentation so short insight into geometry-driven interoperability between Karamba and different platforms. And I'm sure there are many people who might have more additional questions. So here I've also put Nathan's email, where you can write him directly. As Nathan has already mentioned, you can take a look at their website, where you can find all the different plugins, as well as the technical documentation, where it's very, very in-depth and well documented. So definitely get in touch with them if you're interested in investigating these tools. Any last words from you, Nathan or Jon?
No, thanks for having us. No, it's been great.
Thank you. And thank you everyone for attending. And next time, I think we are back in 2 weeks. I just want to mention we are actually having a short webinar investigating Karamba IDEA, and I don't know if many people have been using IDEA, but basically you can now export your Karamba models into IDEA, where you can do detailed steel joint analysis. So more details will be announced on the website in the coming weeks. So look forward to this. And thank you once again. Thank you, Nathan and Jon.
Thank you.
So